Hello and welcome to a new episode of the Data Science Daily series. And I'm very excited to have you here back again. Today's session is going to be about nested comprehensions with conditionals. So, in the last session, we discussed the conditional statements like if, else, and else if, and we looked at a question on dictionary comprehension, which was kind of a basic question. Today, we are going to spice it up a little bit and go further into nested comprehensions using conditionals. And this is going to be complex problem solving with two problems. So make sure you're following each part of it. As always, pause the video after the question has been introduced, try to solve it by yourself, then come back to the video and see the different answers, the different ways to answer the same question, basically. So without further ado, let's get started and hope you have your Jupyter notebooks ready for this challenge today. All right. So the first exercise is finding Pythagorean triples. Now, what are Pythagorean triples? Basically, a Pythagorean triple ABC is such that a squared plus b squared is equal to c squared. That is what we say when we say we are looking at the Pythagorean triple, right? Think of it as a right angled triangle. So the question is find all the Pythagorean triples for numbers between 1 and 100, both included, that is 100 should be included and 1 should be included and everything in between, where basically that set of three numbers is a Pythagorean triple where a squared plus b squared is equal to c squared. Now, how would you solve this? Just a reminder, pause this video, try to solve it yourself and then come back to this. Now, first method without using comprehensions at all. So I define a triples set 1 as an empty set, right? And then what I say is for a in range 1 to 101, remember 1 will be counted, but 101 will not be counted because this is the stop. So it will only go till 100. So from 1 to 100, the a value ranges. Then inside this for loop, there is another for loop for b in range 1 to 111. So b ranges from 1 to 100. And within that, there is another loop for c, where c ranges from 1 to 100. So why I have done three nested loops is so that we can have all the combinations of A, B, and C. And basically, then I'm checking if A squared plus B squared is equal to C squared, triples set 1 dot add ABC, and I am adding it as a tuple, right? Now, this will work. This triple set 1 will have all the combinations of A, B, C, which basically satisfy the Pythagorean triple formula. So if I run this, right, and let me also run the white statement. Okay, so I run this and I see the length of this particular set. So the length of the set is 104. And what's happening is you can see one interesting thing happening here, which we actually do not need. What's happening is that when A is ranging from 1 to 100, B is also ranging from 1 to 100. So there can be cases where you're looking at the same triple, but the order is flipped. How I mean is, you're looking at 3, 4, and 5, where we know that 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 is 25. But in just the next element, you're looking at 4, 3, 5, which is actually the same Pythagorean triple, right? It's the same exact triple, but it has been counted twice just because the order of A and B has been flipped. You can see this happening multiple times where the order of A and B is mainly flipped. So you can see 5, 12, 13 occurring here and 12, 5, 13 again occurring towards a later part. So what exactly is happening is all the triples are actually exactly repeated twice and we don't want to repeat them, let's say. That's the main reason why we are creating sets in the first place. So how do you solve this issue? How do you solve the issue of repeating and you don't want these to repeat? Now, the reason they are repeating is because A is also ranging from 1 to 100 and B is also ranging from 1 to 100. So there are scenarios where A is less than B and there are scenarios where A is greater than B for the same value of C, right? For the same value of C, like 13 here. First, A is less than B and you're getting 5 and 12. In the second case, A is greater than B, so you're getting 12 and 5, where actually these are the same triples. So how do you solve this? How you can actually solve this is, let me go to the solution. So you create, again, we initialize a new set, triple set 2, and A is still ranging from 1 to 100. But now We are ensuring that B is always greater than equal to A. How do we ensure that? When we are defining for B in range, inside the range, we keep the start as the value of A, right? The iterable A basically is the start for the loop of B, and 101 is still the end, right? So for A in range 1 comma 101, for B in range A comma 101, so it's always A, B is greater than equal to A. And you can see in the next loop also for C in range B comma 101, right? So C is greater than equal to B, which is obvious, right? Because if A squared plus B squared has to be equal to C squared, right? Um, C has to be greater than equal to either B or A, basically, right? So here we are saying for C in range B comma 101, right? Which is a more stringent condition because B is greater than equal to A, and we are saying C is greater than equal to B. So C is all automatically greater than equal to A, right? So for C in range B comma 101, and then we are trying to basically do the same thing where we are adding the Pythagorean triples as tuples to the set. So you run this and you will see now that the length of this particular set has become 52. It's exactly half of what we were seeing earlier. It was 104. And if you print those tuples or the set of tuples, basically you will see all the Pythagorean triples, and this is the correct set output, right? You'll see that none of these are repeating just because of the constraints that we have put. And this is a much cleaner solution, right? Okay, let's go to the next method. How do you do this using comprehension? Because our discussion is completely about comprehensions. So can you think of a method? How do you do this exact same thing using comprehensions? So what you do here is basically you have 3 for loops and then you have an if statement. So if you remember from our comprehensions discussion, what you will do is you will first keep the expression, right? You'll keep the expression of the tuple A, B, C, and then you will just write the for loops as they are occurring, right? So the top for loop, which is for A in range 1 comma 101, then for B in range A comma 101, and then for C in range B comma 101 if A squared plus B squared is equal to C squared. So this triple set 3 is now using a comprehension, right? It's using a set comprehension to be precise. So the expression is A comma B comma C, and then for A in range 1 comma 101, for B in range A comma 101, for C in range B comma 101, if A squared plus B squared is equal to, which is a comparison operator here, C squared, right? Now, the question might arise is, okay, I'm defining different for loops. Then how can I reference A here when I'm defining the for loop for B? The reason is because when you're writing it like this, it starts from the left if you're having multiple fors, right? The first for is basically getting executed first. Then the second for is getting executed. And then the third for is getting executed. So it automatically understands what the value of A is in the for loop for B because the for loop for A is already executed. So I run this and I will see the exact same output. 52 is the set, the length of the set, and these are the elements, or these are the tuples within that set. And if you want to check whether the output from the third method is the same as the output from the second method, we can do that. And you just compare it and it's true. Whereas if you compare from methods 1, for example, it will be false. Right? These are not the same because that was of length 104. This is of 52 length. Hope this is very, very clear what we have done, how we have actually created Pythagorean triples starting from 1 to 100. And questions like these are very common when you're just starting out in coding. You want to think programmatically and you want to sharpen your analytic edge, right? You want to think analytically. Now let's come to the second question. Student grades dictionary. Given a list of students, Alice, Bob, Charlie, Dan, and their respective grades in math, which is 80, 70, 90, 50, and chemistry, right? There are 2 parts of this question. The first part is map the students that have passed that subject against that subject. So for example, I want a mapping of which all students have passed math and which all students have passed chemistry. I want the names basically. That's part 1. Part 2 is saying find the students that passed all the subjects. Now the focus is which students have actually passed all the subjects. In this case, there are just 2 subjects, right? Note that the passing cutoff is set as the average of the class for each subject. For each subject, basically anything above the average is set out as the cutoff, right? And here we can consider the class to be of 4 students only because there are just 4 students in our current data, right? Okay, so let's look at some initial steps first. I'm defining a list of students, right? Alice, Bob, Charlie, Dan. I'm defining the subjects list, which is math and chemistry. I'm defining the math grades 80, 70, 90, and 50, and the chemistry grades as 2 lists, right? So I run this. And then I'm defining the passing grades, right? The passing grade for math is nothing but the mean of the grades of math, right? So sum of math grades divided by length of math grades, right? This is a formula for the average. Similarly, for chemistry, I'm also creating the average. And then I'm just printing that the math pass grade is 72.5 and chemistry pass grade is 61.25. So these are our initial steps. Now we can proceed to the solution. What is the first method? Now the first method is I define an empty dictionary, subject underscore grades. And then I update this with math and chemistry separately. So first I update this with math as key and the value as the names of the students who have actually passed math. So for that, I'm defining the list of students that have passed math as an empty list first, right? Then what I'm doing is I'm using the for loop. So for I comma student in enumerate students, right? So enumerate is one of the functions that we had discussed in a few sessions back. So what enumerate does is it gives you a counter as the first output, and the second output is actually the item itself in that iterable, which is students here. So I comma student, I will always start from 0, and with that the student's name will be accompanied. So for I comma student in enumerate students, if the math grade of that student, right? So I am indexing now the math grades list, which is this list, with the index of that student, right? So if it is 0, it will give me 80. So if it is Alice, right, what will happen is it will return 0 comma Alice. The enumerate first, it will return 0 comma Alice. So 0 will be the index, Alice will be the student name. For 0, basically I'm getting the math grades, right? So that will be 80. If 80 is greater than equal to 72.5, then I'm appending the name of the student, which is Alice, right? And then I go back to the top of the for loop. I take the next instance, which is 1 comma Bob, right? I becomes 1, student becomes Bob. Now for us, math grade of Bob is 70, right? Which is not greater than equal to the pass grade, which is 72.5. So this will basically do nothing. It will not get executed at all. And so on, it keeps on going. So I get a list of students which have passed math, basically, in student underscore math underscore ls. And then I simply just update the subject grades dictionary with key as math and the value as the list of students who have passed math. I hope this is very clear. If it is not, make sure you're pausing the video, rewatching this section, because this is the basic method to solve this question, at least the part 1 of this question. Similarly, we'll do this for chemistry, and we'll define an empty list for the students who have passed chemistry and keep appending the names to this list and assign finally a key name called chemistry to the dictionary and the value as the list of students who have passed chemistry. And if you see the output subject underscore grades, this is what it is. So math, Alice and Charlie have passed, and chemistry, Charlie and Dan have passed. So this is the first method. This is what would come to your mind when you're just thinking about the problem and starting to solve it. Now, there are ways to make it more and more efficient. Let's look at the second method. Now, the second method is using comprehension, right? And we are using a list comprehension to be precise. So I'm defining an empty dictionary student subject underscore grades. And I'm first defining what the names of the students who have passed math. So I'm defining on the left hand side, basically the key. I'm introducing a key math, and the right hand side is a list comprehension, which is getting all the students who have passed math. How? We're just compressing this entire for if statement into a list comprehension. We can do that, right? So student, for I comma student in enumerate students, if math grades I greater than equal to math pass grade. So you can see similarities between this list comprehension and what we have highlighted in the top here. So basically student, right? This is what we are getting. We don't need to append it because list comprehension will already give us this. Student, for I comma student in enumerate students, if math grades I is greater than equal to math pass grade. And this is what we are doing here. Similarly, for chemistry also, we can do this, right? And we get the same output, subject underscore grades. All right. Now I'll come to the third method. Now you will think that this is already very optimized, right? Now, why are we talking about a third method? Now, remember we talked in the last session about something called hard coding. And hard coding is where you're basically, based on the question, you are hard coding certain values. Now, the values that we have hard coded here is math and chemistry. And let's say you had 100 subjects, right? I hope no student has to study 100 subjects and give exams. But let's say the student had 100 exams, right? We'll not be doing this one by one, right? We'll not be writing 100 lines of code. So how do you do this in a fashion that can scale up? That is where this method comes in. So first, I need to additionally define another dictionary which maps the name of the subject with this particular string, math and chem. And to give you an intuition why we are doing this, you will see if you want to remove hard coding, you need to make this particular 21st cell and the 22nd cell consistent with each other, right? So that you can scale it up. Now, how do you make it consistent? First, let's identify what is different. So this key is math, this key is chemistry, this is different. And then math grades, math pass grade, chem grades, chem pass grade. These are the differences, basically, right? So you can see that math is different from chemistry, and this math, right? The first four letters of each of these variables, math grades and math pass grade, is different from chem grades and chem pass grade. So if there were a way in which we can make this dynamic, we would be able to remove the hard coding. And there is actually a way in which you can do that, right? Here we introduce the eval function, right? So what the eval function does is, if it is given a string as an input, it actually evaluates the value of that string. To make it more simple, if I'm giving it a string 1 and I'm putting eval brackets 1, right? Now, eval brackets 1 will actually return an integer. It is evaluating what is inside that string. So it will no longer be a string when it is evaluated. It will become an integer. Similarly, you can give variable names as well. So if I'm giving the variable name subjects, right? Remember, subjects is math, chemistry, right? Now, if I say eval string of subjects, it will give me math, chemistry. So here we are making use of this interesting and very powerful function called eval to actually remove hard coding. And how would we do that? We would basically use all of these variables, math grades, math pass grade. We would basically make this dynamic, math underscore grades I. We will first make this a string, right? Where we will remove math from it and concatenate it using a variable and then evaluate it, right? Let's see how that happens so that it's more clear. So what we are doing is subject underscore grades, right, is equal to a dictionary comprehension now. And this is a nested comprehension. Why? Because first you have a dictionary comprehension on the outside, and within that dictionary comprehension, you have a list comprehension for each key of the dictionary. So subject grades is equal to subject colon some expression for subject in subjects, which is the last line. So subject is math and chemistry. So there'll be two keys, math and chemistry, right? And then math will take some value, which is defined by this list comprehension, right? And similarly, chemistry will also take a value, which is defined by this list comprehension. So how do we do this? We are using again the same syntax, which is student for I comma student in enumerate students, right? First part remains the same, right? So we already make this dynamic. We have already made this dynamic. The keys we have made dynamic, right? So subject is the key, which is already been made dynamic. The first part of this list is already the same in both the cases, right? So that remains the same. Now, the issue comes in the second half where we are looking at the if condition. So if chem underscore grades is greater than equal to chem underscore pass grade. Now, I want to remove this chem and I want to map it, right? So I have subject as my variable here, right? Which is capital math and capital chemistry, right? So how do we actually map it? That's why I have defined this dictionary, another mapping dictionary. So wherever this math with the capital M is occurring, basically we will map it to the small math, right? So that's what's happening. I'm creating an eval. So look at this. I'm creating an eval, right? Within that eval, I'm concatenating two strings. The first string is basically nothing but all lowercase math. The one I've highlighted will return you all lowercase math because the subject is math with a capital M, then subject map dict, and I'm calling the value for that key. It becomes all lowercase math. So math plus underscore grades I, right? So this entire string will basically be this string, right? It will be the name, it will be this variable basically, but enclosed within a string. And when I put eval on top of this, it will actually evaluate and be same as this particular variable, right? We have just made it dynamic using the eval function. So if evaluating that particular string, which is actually the name of a variable, it is greater than equal to, similarly, we are doing the same thing here with underscore pass grade, right? So chem underscore pass grade, the chem underscore part of it, it has been made dynamic, right? Or chem has been made dynamic using this particular dictionary mapping, additional dictionary mapping for subject in subjects. And I run this and I will get the same output. Now, the interesting thing here is, right, you just increase the subjects, right? The list subjects, if you just increase that and you just increase the lists, it will automatically scale, right? The grades, if you already automatically increase that, this particular code will automatically scale. So this is where we have just used one single nested comprehension with a conditional to solve the exact same problem statement, right? Although it has become a little complex where we have used the eval function just to demonstrate how do you remove hard coding, it is still very, very powerful. Now let's look at the part 2, where we have to find the student who has passed all the subjects. The first way to do it is you find out the grades of each student, right? So the key in your dictionary will be the student name and the value will be true or false depending on have they passed that subject or not. So what I'm doing is I'm defining a dictionary comprehension, student colon, right? And then this is a tuple that I'm defining, which contains two values, right? Two Boolean values. First Boolean is to say whether the student has passed math or not. The second Boolean is to say whether the student has passed chemistry or not, right? For I comma student and enumerate students, right? So basically that I counter is being used within this tuple where actually the grades are being indexed by that particular counter I for that particular student, right? So that's why we are doing this. And this is giving us an output like this. Alice, true and false. So Alice has passed math, but not chemistry. Bob, false, false, failed both. Charlie passed both, true and true. And Dan has failed the first one and passed the second one, which is passed chemistry, right? And then what we can do after this is you can create another comprehension where you're basically summing up this tuple values and saying where is it equal to 2, right? For which student is it equal to 2? So student overall pass is equal to student for student comma grades in student underscore grades dot items. Remember, dot items will give you kind of like Alice comma true comma false, Bob comma the tuple false comma false, Charlie comma tuple, right? Let's see how this is actually working so that it's very, very clear. So what does this give you? So that you know what you're iterating against. This gives you a dictionary items data type where you're looking at this, right? So here what's happening is in each of these tuples, right? The first element is Alice. The second element is another tuple with true and false, or the two Booleans basically. So if you do this for student comma grades and student underscore grades dot items, basically this iteration is occurring so that student is assigned the first element and grades is assigned the second element, which is a tuple of two Booleans, right? And we are only keeping the student name if the sum of the grades is equal to 2. That is, if you sum the two Booleans up, it basically becomes equal to 2, right? And here you will see that Charlie satisfies this condition. So Charlie has been returned. Now, this is the first method how you can solve it. Let's look at the second method where you can just do it in one single statement, right? Student for I comma student in enumerate students if basically their grades are greater than equal to the pass grade in all the subjects, right? And we have simply done this, right? So we have bypassed the route of actually creating two comprehensions, right? And just done it with single comprehension. So this is more optimized, right? This is where I want to bring to you the notion that even if you're using comprehensions, there is always a way to make it more and more efficient, right? Instead of creating two comprehensions like in the first method, where you are creating first a comprehension, dictionary comprehension, which gives you a dictionary whether the student has passed math and chemistry, right, as booleans, and then you sum up the boolean tuples to find out which student has passed both the subjects. You can simply do it in the second method as a list comprehension, where you're saying for basically just keep that student who has passed both math and chemistry. So we have made use of this particular list comprehension here. Now there's a third method as well, which I want to discuss, but I don't want you to worry too much about it. Why? Because it is a bit complex. But I still want to demonstrate that, because this is another way to do the same question. The first step is, right, I get the values from the first part where we were having the subject name, right? So if you remember the output of the first part, this is the output. You were having the subject name and the list of students who have passed that subject. So I just want the list of students who have passed the subjects as a dict underscore values. So I'm just calling dictionary.values and it will give me this particular output. Now what I want to do is I will create a list of sets, and we will shortly see why I want to transform this particular data type, dict underscore values, as a list of sets. I want to transform it like this. We are not losing or adding any information. We are just changing the data type. And I'll just use a list comprehension to do that, right? A very simple list comprehension. Set of this subject pass ls for subject pass ls in these names, basically, right? So it'll just give me a list of sets, because I'm transforming the expression is a set of expression. And the third step is where the magic actually occurs. So I simply want to take the intersection of this, or the different sets that are existing within that list. So within this list that I've highlighted, I just want to take the intersection of all the individual sets. How I can do that in one line is set.intersection star sub student underscore subject wise underscore pass underscore set, this variable, right? So it's taking the list of sets and it is finding the set dot intersection. And I have to define a asterisk in the beginning, which is basically used to unpack a collection into several isolated values, right? So that's why I'm using this. And if I do this, it will give me the set with one element, which is Charlie, because Charlie is the one which is the output of the intersection of these two sets. Charlie is common in both. So this is another way to do this, right? But you will think that you're doing this in 3 lines of code or 3 blocks of code. Now, why do I want to do that when I already have a very efficient solution? Because you can also do this third method in 1 line of code. And this is the 1-line solution. Set.intersection star, right? And then you have this variable. So this variable is nothing but this particular list comprehension. So you define that list comprehension, where in that list comprehension, you are using this variable subject wise underscore pass underscore names, which you had defined as subject underscore grades dot values. So you just substitute it here. So you're doing the entire 3 blocks of code in 1 line and you're getting the same output. All right, so we have covered quite a lot of ground, and this is one of the more complex problem solving questions in Python that we have actually covered so far. So if some parts of it are not clear to you, I totally understand. I would request you to please go through it again. If you have any doubts which are persisting, feel free to put them in the chat, mentioning which exact code snippet you had issues in and what was the problem that you were facing or the doubt that you had, so that I can resolve it in an appropriate and a timely fashion. So with this, we have covered control flow statements and comprehensions, and we have looked at 5 questions in total, which cover this spectrum of concepts. Next, we will be looking into more and more interesting concepts. So stay tuned. You will be notified shortly. Till then, have a good learning and have a good rest of the day. See you in the next session.